Alright, in the last video we learned how to graph the sine and cosine functions. And in this video we're going to learn how to graph the four remaining trig functions: the tangent, the cotangent, the secant, and the cosecant. So we're going to start with the tangent. And basically what you need to know about these graphs are really two things. What are the basic shapes of the graphs? And also where the zeros are, if they have any zeros, or x-intercepts, where do they cross the x-axis, in other words, and also where are the asymptotes. Okay, so let's start off with the tangent graph. Alright, so we know that the tangent is equal to the sine over cosine. Alright, so essentially, let's just review some basic math. When you have a fraction, the number is equal to 0 when the numerator equals 0, right? So if the numerator is equal to 0, the entire fraction is 0, right? So 0 over 3 equals 0, 0 over 5 equals 0, etc. All right? Now, what if you have a number over 0? What is that? That is undefined. All right? And if you have 0 on the denominator, that means that you're going to have an asymptote. All right? So, what did we just learn? The zeros are going to be coming from when the numerator is 0, and the asymptotes is going to be when the denominator. So denominator equals 0, and this is when the numerator equals 0. Nothing different than what we've done earlier in the year. So let's go back to our tangent graph. All right, the tangent is going to be equal to 0. So let me write this out for you. The tangent of x is going to equal 0 when the sine of x equals 0. And the tangent of x will be undefined when the cosine of x equals 0, because then you'd be dividing by 0. So, in order to figure out what the tangent graph looks like, let's see if we can remember what the sine and cosine graphs look like. So, we'll do the sine graph first. And let's see what the sine graph looks like. Alright, it's going to look like this. And where does it cross? It crosses at 0, at pi, and at 2 pi. Alright, let's go ahead and look at the cosine graph. Cosine graph, it starts at its maximum, halfway through reaches its minimum, and then back to its maximum, and then right here and here. So it's going to cross. So this is pi over 2, and this is 3 pi over 2. Alright, so let's just write this out. The sine equals 0 at 0, pi, and 2 pi. The cosine equals 0 at pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2 and 9 pi over 2 and all odd multiples of pi over 2. So, when does the tangent equal 0? Alright, it's going to equal 0 at those three places. So, we'll put 0, pi, 2 pi, 3 pi, 4 pi, on and on. When is the tangent undefined? Well, it's undefined when the cosine equals 0, so that's going to relate back to that graph. So that's going to be at pi over 2, at 3 pi over 2, 5 pi over 2, 7 pi over 2, forever and ever. Okay, so the tangent is going to look like this. It's going to have a 0 here. It's going to have another 0 at pi. It's going to have another 0 at 2 pi. It's going to have another 0 at 3 pi. Okay, those are all the places where it's going to be 0. And then I'm going to put an asymptote at pi over 2 and 3 pi over 2. Okay, 5 pi over 2. Those are where the asymptotes are going to be. So, if I were to sketch this graph, it would look something like this. Something like that. That's what the tangent looks like. Okay? Notice the zeros. Zeros right there at 3 pi, at 2 pi, at pi, 1 pi, at 0. And then you have your asymptotes in between there. All right? And that is the basic shape of the tangent. Okay? So the next slide we'll do is going to be cotangent. Alright, so now that we understand the basic shape of the graph of the tangent, now we can actually attack the graph of the cotangent, and let's see how they are different. Well, the cotangent of x is equal to the cosine of x over the sine of x. So, the cotangent is going to equal 0 when the cosine equals 0. So, when the cosine of x equals 0, that will lead to the cotangent of x equaling 0. Once again, let me repeat that. When the numerator of a fraction is 0, the entire number is 0. Okay? And the cotangent is going to be, so when the sine of x equals 0, that's going to lead to the cotangent of x being undefined. Okay, so it's the flip of the last problem that we did. So we already established, and you're going to want to memorize these. Let me repeat, you are going to want to memorize these. We've already established that the sine of x equals 0 at multiples of pi. So that's going to be 0, pi, 2 pi, 3 pi, on and on. And the cosine of x equals 0 at pi over 2, 3 pi over 2, 5 pi over 2, and on and on and on. All right? So you're going to want to memorize those, and you'll see why later. So let's see if we can graph the cotangent. I am going to, this time, I'm going to put zeros at the places where the cosine is 0. So that's going to be pi over 2, and that's going to be 3 pi over 2, 5 pi over 2, so on and so forth. And I am going to put asymptotes at the place where the denominator is 0 or the sign is 0, because you can't divide by 0. So I'm going to put asymptotes at all of these places right here. So I'm going to go ahead and put asymptotes there, and that's going to be at 0. So let's just put one there, 0. And pi, and 2 pi, 3 pi, and you can actually go backwards here and do these as well on the other side. Okay, and so that's going to be another asymptote there, and I think you get the picture. So the cotangent looks a little different. This guy is going to be coming from here down like that, and coming down like that, coming down like that, and down like that. Alright, so that is going to be the cotangent. And you notice that the cotangent starts up, so let me circle that, starts up and ends down, whereas the tangent started down and ended up. Alright, and that is the basic graph of the cotangent. Alright, let's attack the secant and the cosecant graphs. Alright, first thing we need to understand is what is the secant and what is the cosecant. Well, this is review. The secant of x is equal to 1 over the cosine of x. Alright, so let's just kind of analyze this a little bit. Once again, we want to ask the question, when is this equal to 0? Question mark. And when is it equal to undefined? Okay. Now let's just think about this for a second. What has to be true in order for a number to be equal to 0? A fraction to be equal to 0? Well, I just said it before. The numerator of a fraction has to be equal to 0. Well, you can see here that the numerator is always 1. 1 will never equal 0, obviously. So therefore, this overall fraction will never be 0 because you will always have a 1 on the top divided by some number on the bottom. That's never going to equal 0. So therefore, the secant graph will never equal 0. Now, where is the secant undefined? Well, we've just gone through this. It will be undefined when the denominator is equal to 0. Well, what's on the denominator of the secant? Cosine. There it is. So when will the secant be equal to 0? The secant will be equal to 0 at the same points when the cosine is 0. So when the cosine is equal to 0, the secant will be undefined at the same places when the cosine is 0. So I misspoke. So the secant will be undefined at what key angles? Pi over 2, 3 pi over 2, the same things that we've gone through before, 5 pi over 2, so on and so forth. All right. Now, let's see if we can figure out what the basic shape of this is. Well, this is kind of cool. All right. In order to get the shape of the secant graph, all you really need to know how to do is memorize the shape of the cosine graph. So let me draw the cosine graph for you. Okay, that's one cycle. It's another cycle. All right. Now, the secant is 1 divided by the cosine, or it is the flip of the cosine. So watch this. All you really need to do is take the cosine graph, and on top of it, just draw, oops, this should actually go on up there, so there we go. All right, and there's that, and you can do this all the way around, and now you have just drawn the secant graph. The secant, once again, is the reciprocal of the cosine. You say, Mr. Parr, how does that work? All right. Well, let's take an example. All right. Let's say this point that I just highlighted is the point, let's say the y value is 1/10. Okay. If you flip that, what is the flip of 1/10? 10. So that's the reason why on the secant graph, you've got to be all the way up here at 10 now instead of 1/10. So, something else that we want to understand is, where is the cosine 0? Well, it's 0 there, it's 0 there, it's 0 there, it's 0 there. So every time the cosine is 0, the secant will be what? Undefined. So therefore, what do we need to draw? We need to draw in some asymptotes right there. Every time the cosine is 0, we need an asymptote. And that is the basic shape of the secant. All right? And you can see the cosecant is going to work the same. The only difference with the cosecant is that the cosecant of x is equal to 1 over the sine of x. So it's going to have, if we draw the sine graph, let's see if we could draw the sine graph. We'll do this one really quickly. Sine graph is going to be this guy. All right, let me extend the x-axis out a little bit. All right, and draw it backwards a little bit too. All right, so what is the cosecant graph going to look like? Well, it's just going to be the flip of that. Flip of all these right here. All right, that's it. Really simple. So once again, the cosecant will be undefined every time the denominator is 0 or the sign is 0. So that's going to be at these places right here, and here, and here, and here, and here. So we need to draw asymptotes right there. And right there, and all the way down. And that is the graphs of the secant and the cosecant. All right, we're going to do a few examples of finding the zeros and asymptotes of these 4 trig functions when you have transformations involved. All right, so let's say we'll start with, we'll start with tangent of 3x. All right, now tangent of 3x can be written as sine of 3x over cosine of 3x. Now you have to remember from earlier in the year, what transformation is 3x? Well, that's counterintuitive. It is inside the parentheses, so it must be something horizontal, and it's counterintuitive. So 3x is really a horizontal shrink by 1/3, right? We talked about that at the beginning of the year. So what you need to do is, if you're looking for the zeros of this function, what you want to do is you want to take the normal zeros of the numerator and divide them all by 3 or multiply them by 1/3. So let's just write out the normal zeros, and hopefully you're picking up on this. The normal zeros of the sine function are 0, pi, 2 pi, 3 pi, 4 pi, and let me actually add something to this problem. Find all the zeros, so let's just say find all the zeros and all the asymptotes in the window of 0 to 2 pi. So we'll find all the places where the tangent crosses, tangent of 3x crosses from 0 to 2 pi, or where it's undefined. So also we're going to take the normal places where the cosine is 0, which is going to be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, comma, dot, dot, dot. All right, and what do we want to do with these? We want to multiply them, those lists, by 1/3. We want to multiply by 1/3. So let's see what we get. Our real zeros of the tangent of 3x are now going to be 1/3 times 0, which is 0. 1/3 times pi is pi over 3. And 1/3 times 2 pi is 2 pi over 3. And you can see 1/3 times 3 pi is just pi. And 1/3 times 4 pi is 4 pi over 3. Now we've got to keep going until, look, we get to 2 pi. So we got to keep going. So you can see the pattern. Some of you are just going to pick up on the pattern. 0 pi over 3. We'll put maybe a 1 pi over 3, 2 pi over 3, 3 pi over 3 which reduces to pi, 4 pi over 3, and we can just see, okay, 5 pi over 3, and then 6 pi over 3, which is 2 pi. All right, so these are the zeros of the tangent of 3x. Now, where are the asymptotes? Okay, so the asymptotes are going to be, once again, where the denominator equals 0. So we have to take the normal places where the cosine is 0 and shrink them by 1/3. So we're going to multiply this fraction in there. So that's going to give us pi over 6. And then we're going to multiply 1/3 in there. And that's going to give us pi over 2, or 90. And then we're going to multiply 1/3 in there. That's going to give us 5 pi over 6. And 1/3 in here. That's going to give us 7 pi over 6. All right. Are you catching the pattern? 1 pi over 6, 3 pi over 6, which reduces to pi over 2, 5 pi over 6, 7 pi over 6. Oh, odd numbers, 1, 3, 5, 7. So 9 pi over 6, which reduces to 3 pi over 2. And then 11 pi over 6. And then you're done, because 13 pi over 6, watch this, 13 pi over 6 is greater than 2 pi. 6 goes into 13 two times with something left over, so you don't need that. You can stop at 11 pi over 6, and these are the asymptotes of the tangent of 3x. These are the places where it crosses at 0. All right, so most of the problems that we'll ask you are going to be similar to this type of situation. We'll do another one on the next slide. All right, let's say we are given, we want to find the secant of x over 2. And we want to find, once again, where are the asymptotes? Because we've already established that the secant does not have any zeros, so it will never equal 0. Okay? But it will have some asymptotes, because this is 1 over the cosine of x over 2. All right, now do you guys remember what is happening when you have an x divided by 2? It's inside the parentheses, so it's horizontal. If it's horizontal, it is counterintuitive, so it's backwards. So it's really a horizontal stretch. Horizontal stretch. All right, by 2. So therefore, you can see what you need to do here. You're going to take the normal places where the cosine is 0. So that's going to be what? Pi over 2. Okay, same thing. 3 pi over 2. 5 pi over 2. 7 pi over 2. Comma, dot, dot, dot. And you're going to now multiply them by 2. Okay, so because you're stretching it, so you're going to now multiply by 2. Now these you like because you're only going from 0 to 2 pi. And so notice we're not going to have as many solutions this time. You're going to distribute the 2 in there. That's going to give you pi. Then you're going to distribute the 2 in here. That's going to give you 3 pi. And you're done. Because 3 pi is bigger than 2 pi. So therefore, look at that. Only one solution, pi. Okay? Now, just to let you know, sometimes we'll change it up and we'll say all solutions from negative 2 pi to 2 pi. In that case, you would just have to put a plus or minus on your answer, and then you're done. All right? So that's basically how you do it, guys. The zeros come from the numerator, and the asymptotes come from the denominator. And anytime you have a transformation, it's normally going to be a stretch or a shrink, something like that. You just need to take the normal places where these functions are 0 and either multiply them by a factor bigger than 1 or a fraction smaller than 1. And that's how you do it.